Hi everyone. So today here we are going to have first application of derivative, how to get absolute or global extrema. Extrema here means minimum or maximum over the closed interval. They give you closed interval. So here suppose that you know that the price of the stock certain company will follow this graph. Here is the graph, starts from A here, that is your A, and then the course of a week. So that is like this graph is due a course of a week, although you would certainly here make handsome profit if you buy with the low price here A and you try to sell it on in B, which is the highest price, right? So that will be a good strategy. So our goal here is let us give characterizations about the minimum and the maximum here. If you look to the graph starts from, it's called domain, the interval A to B. So the whole graph starts from A to B. So A, B here we call it end point. End point means the graph starts from A and is going to end to B. So starting from A, end to B. So because of that we call it end point. So A we call it initial point, B we call it end point. And here you could have, if I look to this domain, that is your start from A to B, the whole domain is A to B. Then I have divide this to subdomains or subinterval. So if I look from A to C, that is subinterval, C to D, and D to E, and E to K, and K to B. So that is called subdomain or subinterval. So if I look from A to C here, if I look to the interval A to C, then what is the minimum? What is your minimum? Remember, that is a graph here, that is for your F. So the minimum here should be the value of F at, so if I put here, that is F at A here. So that is your minimum of your F, not your A at A and C. So your minimum always for your F, because that is represent a cost or a price, and then it will be the minimum. So here, if I look, where is the minimum? It will be F of A, that is your minimum. What is your at C here? That is your, so I'm going to write here, maybe I write minimum and maximum. So here minimum, so that is your minimum here, and then your maximum here. So what is your minimum? It will be the value F at A. What is your maximum from when I look to A to C? Then your maximum here is F of C, F of C. So now if I go from C to D, so what is your minimum and what is your maximum? F of D, that is minimum. F of C, that is your maximum. Again, you keep continue from D to E, and then from E to K, right? So E to K, right? And then you have from K to B. So if I try to look for this one by one, so here D, from D to E here, that is D to E here, just look to D to E. So what is your minimum at D, right? Your minimum here at D, and what is your maximum here? It will be at E. Your maximum here at E. If I look to from E to K, your minimum K, right? Your minimum at K, and your maximum here is at E here, at E. Last one from K to B here, your K you have minimum, your K you have minimum, and your maximum here F of B. So now, as you can see, we have, when I look to subinterval or subdomain, I have here, I work in, we call it local. So here I'm not looking for the whole pictures, I'm looking for subinterval or subdomain. So your AF at A here is a local min. Your C is a local max, F of C local max, F of D local min, F of D again local min. So all of this will become locals, local minimum or local max. So now if you have local, sometimes we call it relative. So you have, could be minimum, right? In our case here, that is, or the whole thing, that is your minimum here, the whole thing here, that is our minimum, and that is the other one here is your maximum. So we call it here, so local or relative, that is the definition, we call it min or max. we call it extrema. So word extrema here, extrema means could be minimum or could be maximum, could be minimum or could be maximum. So here when you work in local subinterval or subdomain, then we have local min or local max. But if I look to the whole domain, here is start from A to B, the whole domain, then I look to the smallest value that you have and the largest value you have. We call it global min or global max, global, or sometimes we call it absolute, global or absolute. What is absolute or global extrema? So that is will be the smallest value of this. You have global min. If you have absolute, the smallest value, so that it will be the smallest value for the entire domain, the smallest value in the entire domain. Global max, it will be the largest value of my domain, largest value of your domain. All right, so now I'm going to, so when I look to subinterval, subdomain, then I'm working on locals. If I look for the whole pictures, for the whole domain, where is the graph start, which is at A, where is the graph is going to end at B, then we have the smallest value you could have, that it will be your global minimum or absolute minimum. If you have the largest value for the whole pictures, here it will be global max or absolute max. Okay, so now let us look for this one. So here at A, here A you have minimum, at B here you have maximum. So this point, so let me give characterization where we have minimum or maximum, at what kind of point you have minimum or maximum. Turn out at A, that is you have minimum, which is, you call it end point. So here the first category you could have, we call it could be end point. That is a point where you could have promising point, you could have minimum or maximum. So now if I look to this one here, look what you have, this one. So now I need to have characterization where you have minimum or maximum. So this one you have here maximum, but you look to this one here. If I make horizontal tangent here, horizontal tangent, so let me explain here. So here you have horizontal tangent here, and here also you have horizontal tangent. Here you have horizontal tangent. I don't have here this, so here you have horizontal tangent. So that is f prime of C, and this one here f prime of D, and this one here f prime of E, right? So what happened here for the derivative is the derivative here is 0. Why is the derivative here 0? So f prime of E is 0, f prime of D also here 0. So let me show you, explain that. So I have f prime of, let me explain, f prime. So here at C 0, f of C here, 0, and the f prime of, let me write the number here, D and also E, D and E. So that is your E here, and that is your D, and that is your C. So f of D also D, just let me write it, f prime of D equals 0, f prime of E equals 0. Why this? If I have something like this, right, it could have something like this. Why I have here the derivative is 0? That is, you know, I gave you before, I said what is the slope? The slope here is your derivative at specific number. Your derivative at specific number, we call it here just a number here. If it, so at say x equal E or just a C, that is not the same C. So the derivative at A, that's what I gave you. Remember when I called the definition, limit h equals to 0, f of A plus h minus f of A over h. I said here that is your slope, your derivative. But also f here, it could be nonlinear functions, and we mentioned before, in order to get the slope here of your f of x, just nothing but it will be the derivative at specific numbers here, a specific number that gives you the slope, but also does he give you the slope of the tangent line, right, of your f of x, f of x at x equal a, at x equal a. So what is tangent line? It's a line, tangent line, it's a line touch the curve or the graph at most one point. Is a line touch the graph or the curve at most one point. That is called here, we call it tangent line. So if I ask you what is the slope of the tangent line of your f of x, it will be your derivative at a. Now let me recall, guys, here, let me recall for you, let me recall what happened if your derivative, so here for slope here, if I give you y equal 3 or just 3 constant, that's a constant function here. What is the graph of this? It will be y equals 3 here. That's a line like this, horizontal line, horizontal line. So what is the slope? What is our slope of any horizontal line? Slope of any horizontal line. The slope of any horizontal line, the slope of any horizontal line is 0. Why? Why? Because the slope is a change in y over a change in x, but y is fixed. Y here, there is no change in y. So if what is your, if you take two number here, that is your x1, say 1 and 2, then what is the number here? So it will be 3 minus 3 over 2 minus 1. So what did you get? You get 0 over 1, or 0 over any number, you get 0. So the slope of any horizontal line is 0. So right, but how that is if you have a line, if you have a line. But now if you have a tangent line, if you have a curve like this, right, and then the slope here is what? The slope, that what is the slope here? That's called tangent line. So what is the slope of this tangent line? It's a horizontal line. Our tangent line here is horizontal. If I have like this also, it's horizontal like this. So this slope here, so your slope here, that's this one, if that is your c, then your f prime of c, that is your slope, and that is should be 0. If here c, then your derivative of c equal 0, because you have horizontal tangent. It's a line, but horizontal means the slope of any horizontal line is 0, and then your f prime of c equals 0. So that is the reason, if I go back to here, f prime of c is 0, f prime of d 0, f prime of c, f prime of e equals 0. That is from the line here. If I look at the graph, this point here, because you have horizontal tangent, and the slope of any horizontal tangent is 0. The slope of the tangent line here exactly the same like slope of your f of x here, but at this point, which is c, at this point, which is c. Likewise for d, the slope of this function here at d should be 0, because you have horizontal tangent, and here also at e have horizontal tangent. This point where when you have horizontal tangent or the slope is 0 or your derivative is 0, we call it a stationary point. We call it a stationary. So here, stationary point. So stationary point, I just write it here, stationary point. So that is a point x equals c is a stationary point, right? So if you have stationary point, just write here, if you have your first derivative at c equals 0, and also your c must be inside the domain. So you have two conditions. Condition number 1, your derivative is 0, and we'll call it the stationary point. That is, what is derivative is 0 means you have horizontal tangent, your slope is 0, that is your slope or your derivative at c equals 0, and c must be also inside the domain of your f, the domain of our f here. So that is called the stationary point. So like for our example here, if I go up here, so what is your stationary point? That is your c, that's 1, your d stationary point, because you have your slope is horizontal tangent or your derivative is 0, and e. So c, d, e, that is, we'll call it a stationary point. So you have end point, which is a and b. Where is the graph start? Where is the graph end? That is, we call it end point. And they have another point where you could have minimum or maximum, which is, we call it a stationary point. We call it a stationary point. Okay, guys? So here, so there is another point, another category where you could have minimum or you could have maximum. So here that is another category where you could have minimum or maximum, called the stationary point. And last one here is a point where you could have minimum or maximum here. This point, which is K. What is this point K here? We call it here singular point. We call it singular point. Why singular point? And let me explain. So when you have like V letter, like V or sharp, very sharp at here, then the derivative here does not exist. But still you could have minimum or maximum. So here another category is called here singular point. Singular point. What is singular point? Singular point. So singular point here, x equals c, is a singular point. Singular point, I'm going to explain. Singular point if condition number 1, your derivative at c does not exist. Does not exist means you are not able to exist. Number 2, you have c must be inside the domain. Your c inside the domain. Inside the domain. Okay, let me show you, explain here what is a singular point. What this mean when your derivative does not exist? What does this mean when the derivative does not exist? Okay, so here derivative does not exist. For example, here if I take f of x equal absolute value of x, what is the graph of this? The graph of absolute value from high school, it's like a V letter like this. So that is the graph. That is your f of x, and that is my x. And that is absolute value of x, absolute value of x, which is like V letters. But what is the definition of absolute value? Absolute value could be x or it could be negative x. X when you have x greater than or equal 0, negative x when you have x less than 0. So here, that is the reason you have like a V letters. Look to 0 here, that's our 0. So here negative x, and that is your x. But both of them, they are absolute value, the graph of absolute value of x. So now, what happens if you take the derivative? I need to get the derivative at 0. You know what is the definition of the derivative? The definition of the derivative, it will be limit h close to 0, f of a plus h minus f of a over h, right? So now I'm going to figure out what is your a, 0, because I need to take the derivative at 0, limit h close to 0, f of 0 plus h minus f of 0 over h, right? So that is our definition of the derivative. Now I have to consider left limit h close to 0 from the left, here. When I say h close to 0 from the left, right, so here is 0, right? I come from the left means your h less than 0. When I have h close to 0 from the left means your h less than 0. I have h close to 0 from the right, so h close to 0 from the right, so which means h greater than 0. Here is your 0, I am coming from the right, which means something bigger than 0, right? Very close to 0, but is come from the right. So now I have to consider what happened for the left limit. So h close to 0 from the left, so this one here, it will be what? So it will be f of h minus f of 0 over h. So here I have to consider h less than 0. So what is your f of x? Your f of x here is absolute value of x, right? So what is f of h? If you know h close to 0, so I said here two things. Here x greater than or equal, it will be x. If you have x greater than or equal 0, negative x if you have x less than 0, right? So now if I take f of h, and you know h is less than 0, so that will be absolute value of h. So it should be h if you have h greater than or equal 0, or negative h if you have h less than 0, right? So now I'm considering from the left limit h close to 0 from the left means your h close to less than 0 means your h less than 0. So now if I go back here, this one, what is f of h? F of h here will be negative h here because h less than 0. H less than 0. If h less than 0, I have to consider negative h. So we have f of h minus f of 0 over h. But what do you know? You know h less than 0. So this derivative, that is our derivative, f prime of 0, right? That's the definition. This one, it will be negative h. f of h, negative h, because h less than 0, I have to consider this one here, right? Negative h. What is f of 0? Just 0. F of 0, 0, just when x equals 0, then you replace 0 inside, then you have 0 over h. So what did you get? You get negative h over h, which is negative 1. H cancel with h, you get negative 1. So now when I take the limit h close to 0 from the left, limit any constant should be the same constant. So f prime of 0, it will be almost negative 1. Almost negative 1, right? There is left derivative. That is our left. Now, if I repeat the same, when h close to 0 from the right means h greater than 0, then you have f prime of 0, limit h close to 0 from the right, f of h minus f of 0 over h. So now, if I go back here, these functions, h, what do you know about h? Should be greater than 0. H greater than 0, then what is your f of h? Should be h, because h greater than 0, I should have f of h should be h. So if I go back here, f of h, it will be h minus 0, f of 0, 0 over h. So I have to take the limit of the right limit here. H cancel with h. What did you get? You get limit h close to 0 from the right 1, which is 1. So what is going on here? Your left limit or left derivative does not negative 1, and the right derivative is equal what? Is 1. Right derivative is 1. So the left one is negative 1. The right one is 1. So because here your left derivative is not equal to left derivative does not equal to the right derivative, is not equal to the right derivative, then your derivative does not exist. The limit should be the derivative does not, just right, the derivative, right, does not exist, right? So that is when I say does not exist. So which means your f prime of 0 does not exist, and then we call this one here singular point. We call it singular point. So the singular point at 0, x equals 0, when your derivative does not exist, we call it singular. So as you can see, the v letter here, that is your absolute value at 0. So this one is very sharp like this, we call the derivative does not exist. So if you have something sharp like this one here, down like this, also the derivative does not exist here. If you have something sharp like this, it will be your derivative does not exist, and we call it here singular point. So now what is the conclusion? The conclusion from this one here, I have something called local extrema or global extrema. Local minimum or maximum. If you look for sub-interval or subdomain, which one is the smallest value, then you call, oh, that's local or relative. Local or relative. If you look for the whole domain from A to B, then we have global extrema, global min, global max, and that it will be the smallest value you have, we call it global min. The largest value you have, we call it global max. And now what kind of point, promising point or potential point you could have minimum or maximum? We mentioned it could be at the end point, start and end point. That is where you could have minimum or you could have maximum. That's one thing. Number two, you could have at stationary point, that is your derivative is 0, or singular point, that is when you have something sharp like this. Okay, so there is 3 type of point. That is a conclusion. 3 type of point. You could have minimum or you could have maximum. We have singular point and stationary point, and then we call it critical point. So critical point. So this one we could have critical point, we call it singular point. You could have singular point, right? And we have so-called stationary point, right? So both of them, when I say critical point, it could be one of these. One call it stationary point. That is, again, what is stationary point? That is when you have your derivative is 0, and when you have your derivative is, so let me come back here. So that is our stationary point. So your derivative here is 0. And C, that's condition 1. Condition 2, C should be inside the domain. All right? So that is 1. singular point, your derivative does not exist, and also your c must be inside the domain, and this case here you have what's called here, you could have here, I don't know what happened here, you could have local min or local max. Okay guys, so that is our all right. So here I'm just okay guys, so here we have stationary point and we have singular point. That is we call it critical point. So in order to your minimum or maximum could happen at critical point, or it could happen at end point. And here I have to let you know that you have global min or global max when you have your domain is closed interval. Your domain here is closed interval. So here just let me write a remark here for you, a remark. So if you have closed interval a to b like this is given, the domain is given, then we have global or absolute min or maximum. Or sometimes you have open from here and to plus infinity like this, that's called half closed. Then you could have also global min or global max if you have at a here. So what is your end point, a and b? Here what is my end point? End point here is only a, because your plus infinity is not a number. Plus infinity is not a number. Okay, so plus infinity is not a number. So here what is your end point? Just a. Your a here is end point. If you have this kind of in domain, then you could have min or you have max. Okay, let me give you one example here. Apply, what is the question here? Find absolute minimum or maximum for the given functions. So what is f of x equal x squared? What is the domain? X equal 4, x between -1 and 2, -1 and 2. All right, so what I have to do here, I have to what point you have first, you could have end point, that is where you have minimum or maximum, which is -1 and 2. Here x between -1 and 2, that is your a and b. So now how to get critical point? So here is critical point. I have to take the derivative first. What is my derivative? Here what is x? What you have? You have x squared. So what is the derivative? 2x. Derivative of this 2x, right? So now let me ask you a question here. What is the domain? The domain is given -1 and 2. That is your domain. So now, do we have singular point? I have to figure out, do you have singular point? Critical point means singular point. So the answer here is no, we don't have singular point. Why? Because your first derivative is 2x, and if you take any number you wish from the domain here, what is the domain? -1 to 2. If you take any number you wish from here, if I put it here, always you get value for your first derivative. Always you get value for your first derivative. So because of that, I don't have singular point, because singular point, a point where your derivative does not exist. But here our derivative exists. You get always value for any real number x from this domain or from this interval. So now I have to go for a stationary point. How to get a stationary point? Stationary point, that is where your derivative is 0. Right, so I have to get your derivative is 0. So if prime equals 0, so that is your stationary point. So you have 2x equals 0. Go ahead and solve that, you get x equals 0. So the question now is 0 inside the domain. If you recall the definition of a stationary point, you have your derivative is 0. Here, look what you have, your derivative is 0. I took the derivative, equate that to 0, and the c must be inside the domain. So is 0 inside -1 and 2? Yes, -1 and 2. So because of that, so x equals 0, inside the domain, inside -1 and 2. So yes, we have stationary point. So now what is the next here? The next here, I have to make a table. And this table, I write here x, and here I write f of x. As you can see, x and f of x. Now, what I have to put in the table, your end point, -1 and 2. Between -1 and 2, what do you have? You have critical point 0. Then I have to go ahead and find f of x. F of x equals x squared. So I have to figure out what is the value of f at 0. So f of this will be 0 square, which is 0. So you have here 0. F of -1, so you have -1 square, which is 1, right? -1 square, which is 1, and here f at just 2, at 2 here, then you have 4. So you have here 1, and here you have 4, right? So here I put your end point. That is a point where you could have minimum or maximum. And also I have to put the critical point, that is where you could have minimum and maximum. I have to find the corresponding value for f, and then I look to the table here. What is the smallest value you have here, smallest value, and what is the largest value you have? And from the table, smallest value is not writing. So here the smallest value, right? So let me write here, the smallest value is, what is the smallest value? That will be your global min, or absolute minimum or global minimum. So what is that? It will be f of 0 equals 0. So your 0 and 0, when x equals 0, look what you have, 0 here, that is your global min. That is our global min, right? What is the largest one? 4. So that is your, this one here, that is your global or absolute max, and this one global min, right? So here your global, the largest one here, your global max is f of 2 equal 4. F of 2 equal 4, so that is 2 and 4. That is where you have your global max. So now the question, what about the other one? What about 1 here, 1, -1? In order to figure out now the smallest one, that is, we call it global or absolute minimum. That is the smallest one. The largest one, we call it global or absolute max. But the other one here, it could be local. But what kind? Local minimum or maximum? I have to sketch the graph to see if it's local minimum or max. So how to sketch the graph? Just locate the point here. So how to locate the point? Know what you have? You have 0, 0. So 0, 0 here. That is 1, 0. 2 and 4. When x equal 2, what is your y? 4. It's here. So that is your f, and that is my x. And the other one here, you're at the table, -1. When x is -1, your f is 1. So you have here -1, and then you get 1. So here -1 and 1 here, this point, and this one 0, 0, and this. So now connect them, just connect them, just to figure out this point is what? Is that local min or local max? So now if I look to the sub-interval from -1 to 0, -1 to 0, that is sub-interval, -1 to 0, then this point is what? Can you, it's clear this point is what? Local or relative. So I have local here, just right here, local, right? So sometimes we call it local, or sometimes we call it relative. So here, so local or relative, relative. What do you have here? That is maximum, right? Maximum, so which is -1 and 1. -1 and 1 here we have local maximum, and I have to tell you that every global extrema is local, but every local cannot be global, right? So here I should write as a remark. What is the remark here? The remark here is every, just let me write it for you, every, so what is the remark here? So every global extrema, right? Every global extrema is what? Is local extreme, right? But the opposite is not correct. So every local cannot be global, right? Every local cannot be global. Okay, all right. So I have to go for another example here to solve more example here. So what is summarize what I did? Step number 1, I look what kind of point where potentially could have minimum or maximum. First, number 1, end point. That is your end point. Number 2, I have to go ahead and find the critical point. Could be singular point, it could be stationary point. And then I bought a table, and this table I bought all my end point and the critical point. I have to go ahead and find the value of your f at each one, and then the smallest value, that is your global min or max, the smallest value global minimum, and the largest value global maximum. The other one, you have to locate each pair, that is x negative 1 and 1, we call it pair 0 0 2 and 4. Just locate them like this and then connect them, then you figure out which one is local, which one is global. Okay, so let me give you another example here, guys. So maybe I go skip the second one because second one it's easy, so I have to do the, I think this one. Okay, so how this one here. So now what is your domain, your endpoint? What is your endpoint here? All right, so maybe I write here, okay, just change the color to make it black, or okay. So here, what is your endpoint here, guys? Your endpoint here is 0 and 2, 0 and 2, x between 0 and 2, that is my endpoint. That is this point, they are potential to have minimum or could have maximum. So now I have to take the derivative. What is the derivative? Just apply quotient rule and simplify. You will get this one, which is x squared plus 1, x squared plus 1 square. So how did I get that? Then I apply quotient rule and simplify, you get the derivative here, right? So now I must find the critical point. So what is critical point, right? So here is the domain is 0 to 2, that is the interval here, 0 to 2. So now if I look to the derivative, now let me ask you a question here. X squared plus 1, x squared plus 1, what do you know about this term, x squared plus 1? The question here is always positive. Why this one always positive and cannot be 0? Always positive and cannot be 0. Why? Because if I put x equals 0 here, what do you have? You have 0 squared plus 1, which is 1. If I replace x plus or minus 1, if you replace x here, if you replace x by plus or minus 1, then what happened here? You have plus or minus 1 square plus 1. So here you get 1 plus 1, which is 2. So if you take x any real number, positive or negative, then or 0, then x squared plus 1 always positive number and always cannot be 0. So because of that, when I look to this term, this one here, I know this term is positive and cannot be 0, is not equal to 0. X squared plus 1, the whole thing squared. So it's a positive, and you have to be careful here because you have x squared plus 1. But if you have x squared minus 1, is this one here could be 0? Yes, it could be 0. This one could be 0, right? When you have x equal plus or minus 1, you have this term is 0. So here we have to be careful. Here, if you have plus in the middle, is okay, this term non-zero. So it's like 1 minus x squared or divided by a positive number, non-zero. But if you have negative, then you have to give attention because you could have 0 down here and then the situation will be changed and it will be different. Okay, so now in a way you have 1 x squared plus 1, it's a positive. So the question now, what do you have up here? This one, it's polynomial of degree 2. The highest power is 2, that's polynomial of degree 2, and this one here, it's a positive term and always non-zero, so which means your derivative always exists. There is no, we have a fraction, there is no, you don't need to worry to divide by 0 because there is no way to have 0 here. Why? Because this term is always positive and non-zero. But here, if you have negative, this one could be 0 when you have plus or minus 1, if you have in the middle negative sign. But here we are lucky because you are in the middle plus, then I don't have this. So now in a way, no singular point, I need to find the critical point. Right? So the critical point here, no singular point, I don't have singular point. Why? Because your derivative always, you right here, your derivative, because your f prime exists meaning you get value for any x from where? From the domain, which is 0 to 2. If you take any number from 0 to 2 and you put it in your derivative here, you'll figure out is always exists, always there is a number. So now I have to have, I don't have singular point, but do we have a stationary point? The answer here is yes. Do we have a stationary point? So let me finish from this. So the answer here, do we have stationary point? Stationary point. So let me finish from this stationary point. So in order to have a stationary point, so you have your derivative equal, so here you have h, so your derivative should be, your derivative h prime 0 should be 0, right? What is h prime? 1 minus x squared over x squared plus 1 square, and that is equal 0, right? Recall here, recall, if you have a over b equals 0, then your a must be 0 and your b cannot be 0, right? Because we cannot divide by 0. So here the same, you have to take whatever you have up, which is 1 minus x squared, and that is should be 0. 1 minus x squared should be 0. If I solve this one here, how to solve this one? You can use quadratic formula, or you can factor. You can factor 1 plus x equals 0. Then your x equal 1, or your x equal negative 1, right? Negative 1 and 1. So now that is a stationary point, yes. But before I say yes or no, I have to check if this one inside the domain or not. So what is the domain? 0, 2, 0 to 2. So the question now is x equal 1 inside 0, 2? Yes. So this one here is a stationary point. But now if I look for x equal negative 1, this one is not. This one is not inside 0 to 2. So because of that, this one is not, negative 1 here is not stationary point. Is not stationary. It is not a stationary point. So now I have to what's called here is not stationary point. So you have, what is the last step? Now I figure out I have to make a table, right? Here is your table. So you have here x, you have your f of x, and then I have to put 0, I have to put 2. Between 0 and 2, I have to put the stationary point, which is 1. Negative 1 is outside this interval, is not in the domain. That is not stationary point, and it's the only one stationary point. So now what is your f of x? Your f of x here, your f of x, just let me finish. Your f of x equal to, your f of x equal to here, just x. So your h of x here, that should be h of x. Your h of x here, it will be 0, right? H of x here, you have x over x squared plus 1, x squared plus 1. So here you have h of 0 equal 0 over 1, which is 0. So I put 0 here. Then I need to get h of 1, right? H of 1. So what is h of 1? What is h of 1 here? So it will be 1 over 1 squared plus 1, so which is 1 over 2. So I write here 1 over 2. And now what is last one here? H of 2. It will be 2 over 2 squared plus 1, which is 2 over 5. 2 over 5. So here 2 over 5. Right? 2 over 5. Now I look to the smallest value you have. That is the smallest value. So your global, just let me write global min. Your global, you write your global min. Your global min. Your global min here is 0, 0. That is your global min. What is your global max? Global max here is your global max. What is the largest value? 1. This one here, that is the largest. 1 over, right? So you have 1. So you have 1 and 1 over 2. That is your largest value, or your global max here. So now the other one here, I need to find what is the other one. The other one, 2 and 2 over 5. 2 over 2 over 5. So here, this one is 0.5 and this one 0.4, right? 1 over 2.5. 2 over 5.4. So I have to locate this one here on x and y. So you have 0, 0, 0, 0. And now let's look to this. You have 0, 0, and you have when x equal 1. So that is 1 here. Then you have 0.5. Maybe I just scale that 0.5. So this one here is 1.5. Then you have when x equal just 2, you have 2 over 5. So 2 here. Then you get 4. So that is 2 and 0.4. Right? So 2 over 5, which is here, 2 over 5, 0.4, 2 and 0.4. So I look to this one here. Just connect them here like this. then it's very clear this one is what? Minimum or maximum. This one here, local min, because you have 2.4, 2.4, right? You have 2.4, and then we have here your local min 2.4, that is your local min. Okay, so let me summarize what I did. I found you have your domain is closed, interval 0 to 2, that is called end point. I have to figure out critical point. Do we have stationary point? That is where your derivative is 0. Do we have singular point where your derivative does not exist? So turn out I don't have singular point because your derivative exists. And then I have to find the stationary point. But two conditions for a stationary point. I got 1 and -1. But I have to check which one inside the domain, and that is the one I should consider. The one does not include in the domain, that is the one I should really escape. And then that is very much our absolute or global min. I looked the smallest value at this global min or absolute minimum, the largest value global or absolute maximum, and the other one you have to sketch the pair here like this, so that 0 0 here and here 1.5 and the other one 2.4. The reason we call this one local min because if I look at the interval from 1 to 2 here, 1 to 2, so here that is your 1, that is your 2, that is sub-interval, subdomain. You figure out this point here is local min. All right guys, so I think here I will stop here, and that is, you have another one here, but I'm going to maybe leave it to you here, so you can try this one here. So what is I want you to try, so you have, when you make the table here, that is the conclusion x and y, or x and f of x or y. So here you will have the following. So here you could have 0.5, just to check that, 2.5, the other one 1, 2, and the other one here 100 and 100.01. So then that is so go ahead, your end point here, and then you find the stationary point, which is 1, and then the smallest value you have here, that is your global min, that is our global min, right? And then this one here is what is global max, right? And the other one here, you have to locate the point to know if it's local min or local max. You have to locate them so that you will have local min or local max. Okay guys, I think that I will stop here. That is this lecture here about global or absolute extrema, and then you have to make a table. And next time we are going to work here, if the domain is not given, then everything become local. You don't have any global. All right, thank you.